Okay, I was grading your assignment 3, and many of you had this notion that um, smaller the value for the assortivity scores or the page rank or even the eigenvector centrality will assign higher the rank for the node. No, actually the ranking depends on the metric that you are looking at and what is the desirable uh, um, range of values for the metrics. So for assortivity or even page rank, these are the two metrics we'll be working in for exam 3. You would prefer a vertex with a larger assortivity value or a larger page rank value. Okay, so for example, if these are the 5 vertices and these are the assortivity values of those 5 vertices, I would prefer to use this node 3 that has an assortivity value of 0.72. That's the largest among the values out there. So I would assign it a ranking of 1. So ranking of 1 means higher rank. Okay, so that's what I want to state here. Higher the value for assortivity, similarly higher the value for page rank, higher the rank for the vertex, which means you'll assign a smaller value for the ranking number. So 0.72 is the largest among these values. So 1 is the largest ranking, which means the higher rank for the vertex. Okay, so that will be a tentative ranking. Then 0.55 is the second largest, so that's the rank 2. And then 0.23 is the third largest value, so that rank 3. And then 0.12, that will be the fourth ranked vertex, and then 0.01, that will be the last ranked vertex 5, rank 5. Now here the assortative values are unique, so your final ranking is same as tentative ranking. Okay. Now when you have ties among the metric values, so for example here vertex 2 and vertex 5 both have 0.23 as the assortative values. So then you would have to break the tie. Okay, so again 0.72 is the largest, so that is the tentative ranking 1, and then 0.55, that's tentative ranking 2. Now you have 0.23 for vertices 2 and 5. So how would you give the tentative ranking? So break the tie in the numerical order of the IDs or alphabetical order of the vertex IDs. So in this case 2 is smaller than 5, so you will give vertex 2 a ranking of 3 and vertex 5 a tentative ranking of 4. And then 0.01, so vertex 4 gets a tentative ranking of 5. So when it comes to final ranking, all those vertices that have the same tentative ranking, you would have to take the average of those tentative rankings. So ranking tentative ranking 1, only one vertex has that value of 0.72, so you just give the same value for ranking for the final ranking. Then similarly tentative ranking 2, only one vertex has the same as the value of 0.55, so the final ranking will be same as tentative ranking. On the other hand, you will notice that there are two vertices with a tentative ranking of 0.23 and 0.23. So you would have to take the average of the tentative ranking values. So it will be the average of 3 and 4. So that will be 3.5. Okay, so if you have 3 vertices with the same value for the metric, we have to take the average of those 3 values. Okay, so here there are only 2 vertices with the same assortativity value, so we'll take the average of 3 and 4, which will be 3 plus 4 divided by 2, that is 3.5. And then vertex 4 has a tentative ranking of 5, so that's the only vertex with the same with assortative value of 0.01, so that will be final ranking of 5. Okay. Now another issue I also noticed in the assignment is if the values are something like this, so 0.231 and 0.232, you could say they are distinct values, but remember we are going through the iterations and we are stopping after a few iterations. So if the values are like so close to the third decimal, so I would say just go with up to the second decimal to decide the uniqueness of the values. So if the values are getting if the first two decimals are the same, then I think you should consider it as tie among the values. Okay, so after the first two decimals, I would really recommend you to consider the values as ties and break the ties like this when you compute the final ranking. Okay, so I'll again write it here. So consider the values only up to the second decimal for uniqueness. If we have scenario like 0.23 and 0.24, then we can say the values are unique. On the other hand, if the values are like 0.231 and 0.232, then we have to consider them as ties and break the ties while deciding the final ranking, tentative ranking as well as the final ranking. Okay. So if it is 0.23 and 0.24, we could consider unique. But if it is 0.231 and 0.232, go ahead and consider them as ties and break the ties depending on how it should be done. Okay. So if you guys have any questions, go ahead and email me regarding this. Okay.